Hi, second graders, welcome back. This week, I get to work with you on math. We are going to review what you've already learned in your classrooms about visualizing as you're reading word problems and showing what you visualize by drawing a tape diagram. When we read to visualize, we're doing the same work that we do when we're reading a book or any other kind of text. But we're doing some specific thinking about how what we visualize is going to help us draw a tape diagram and then use that tape diagram to figure out what we need to do to solve the problem. Please remember that when you read to visualize, you make a mental image in your mind as you read the word problem sentence by sentence. You visualize what kind of action is taking place in the word problem, and you think about what happens because of that action. You also notice when there is no action. Think about what do you see instead. And you also visualize amounts of the objects that are talked about in the word problem. When you choose a tape diagram, you choose it based on what you visualized when you were reading sentence by sentence. Tape diagrams are the way that we show what we saw in our mind. Different people call the different tape diagrams by different names, but these are the ones we're going to use today. Part, part, whole, start, change, end, and comparison. Our first tape diagram is the part, part, whole tape diagram. When we have a part, part, whole problem, we don't have any action. We've just got some stuff. Let's look at this problem. I have 20 seeds. 15 of the seeds are sunflower seeds. The rest are marigold seeds. How many seeds are marigold seeds? When I read that problem, I don't visualize any action happening. I've just got a bunch of seeds. This is what I know about my seeds. I know that I have 20 of them all together. That's my whole. I know that one part is sunflower seeds, and I know I have 15 of them. I also know the other part is marigold seeds. I can see those marigold seeds, but I can't see how many are in the pile. That's the information I'm going to need to figure out. When you look at this tape diagram, can you figure out whether we need to add or subtract? Another example of a part, part, whole word problem is, I have some seeds. 15 of the seeds are sunflower seeds. 5 are marigold seeds. How many seeds do I have? The part, part, whole tape diagram that would show this problem is, I still have sunflower seeds and marigold seeds as my two parts. But now as I'm labeling, I show that I know I have 15 sunflower seeds and I know I have 5 marigold seeds. What I don't know is the whole. I don't know how many seeds I have altogether. Our next tape diagram is start, change, end. Start, change, end problems are very similar to part, part, whole. We just have some action. Let's look at this problem together. My mom had 14 cans of soup. She bought 7 more. There's the action. I'm picturing her buying more at the store. How many cans does she have now? I visualized that my mom already had those 14 cans of soup in her cupboard, and then I visualized her coming in the door with a grocery bag full of 7 more cans. So this is the tape diagram that matches what I pictured. I don't know how many are in the cupboard now, but I do know that my mom had 14 to begin with. And I also know the action that happened as she got 7 more. I'm missing my whole. Do you know whether we're going to add or subtract? Here's another start, change, end problem. My mom had 21 cans of soup. She opened 3 of them. How many cans are unopened? When I visualize, again, I see some action. I see my mom opening some cans. When I look at the problem, I notice that it tells me how many cans she had to begin with, 21. So I kind of picture those all on the counter. That's my whole. I also know the change. I know that she opened 3 of them. So I put my arrow going away and labeled it with the number 3. I have another part, the part that's the unopened cans, and I see them sitting on the counter, but the problem does not tell me how many unopened cans there are. But if I know how many cans I started with, my whole, and I know that we opened 3, I think I know what I need to do to figure it out. Here's one more example of a start, change, end problem. My mom had 14 cans of soup. She bought some more. Now she has 21. How many cans did she buy? In this problem, we know the whole is 21. She has 21 cans of soup altogether. We also know the part that she started with. She started with 14 cans of soup. What we don't know is the part that is the change. We know that she got some new cans of soup, but we don't know how many. Do you notice that even though in this problem we're getting more cans of soup, to find the answer, we're going to need to subtract. We'll need to start with the whole, take away the part that we knew she already had, and that will give us the action or the part that tells us how many new cans of soup Mom bought. Our last tape diagram is comparison. A comparison word problem is a word problem where we are comparing 2 different amounts of something. In some comparison word problems, we know both amounts and we're trying to figure out the difference between them. Sometimes we know one of the amounts and we know the difference, and we have to use that information to figure out the other amount. Let's look at an example together. In this word problem, we read, I have 13 toy cars. My brother has 24 toy cars. How many more toy cars does my brother have than I do? The comparison problem that matches this word problem is what we see below. I know that I have 13 toy cars. I also know that my brother has more cars than I do, so I made his bar bigger than mine. I also know how many cars he has. I know he has 24. What I don't know is the difference between our 2 amounts of cars. But after I draw this tape diagram, I know that if I take this large quantity or amount and I take away the part that is mine, I'm going to be left with the difference. So I'll solve this problem with subtraction. Let's look at another comparison problem. I have 13 toy cars. Okay, I'm visualizing myself with 13 toy cars. My brother has 14 more toy cars than me. I'm seeing my brother's pile of cars, and he has a bigger pile than I do. I know from the problem that his pile is bigger because he has 14 more in that pile. How many toy cars does my brother have? Well, based on what I visualize that I have a smaller bar or a smaller amount of cars, which means that my brother has more than I do. And when I label, I can label myself with 13. And the part that makes my brother's pile bigger than mine are those 14 cars. What I don't know is how many my brother has. But when I look at my comparison bar model, I can see if I put my part together with the difference, I'm going to know how many toy cars my brother has. Now let's visualize some word problems together. Reading Shark read 15 books today. She read 7 fiction books and the rest were nonfiction. How many nonfiction books, did she read today? When I visualize, I see Reading Shark with a pile of 15 books. I see Reading Shark kind of thinking about the books that she has and realizing that 7 of those books are fiction books and the rest of the pile is all nonfiction. That sounds to me like part, whole. One part is fiction and one part of all those books she read was nonfiction. When I look at my problem, I know that she read a whole 15 books. I also know the part that's fiction. I know she read 7 books today. What I don't know is how many nonfiction books she read today. Based on the tape diagram, do you know whether we're going to add or subtract? Let's look at another problem. Reading Shark has 17 books at home. Then her mom got her 14 more books from the Olympic Hills Book Exchange. How many books does Reading Shark have now? I'm visualizing action this time. Are you? I know that the action that's going on is that Reading Shark got 14 more books from Olympic Hills. I also know that she had some books at home already. The part that she had at home already were those 17 books. What I don't know is the whole number of books that Reading Shark has. Do you know whether you're going to add or subtract to solve this problem when you look at the tape diagram? Here's one more problem for us to do together. Reading Shark read 19 books to her friends. She read 4 more books to herself than she read to her friends. How many books did Reading Shark read to herself? When I visualize Reading Shark having 2 piles of books, the pile of books that she read to her friends and the pile of books she read to herself. The words tell me that she read 4 more books to herself than her friends. So I'm going to compare those 2 piles of books, and I think I know the difference. So in my comparison bar model, I know that she read books to her friends and she read more books to herself. I know the number of books she read to her friends was 19. And I know that she read 4 more to herself. What I don't know is how many books she read to herself. But when I look at my comparison bar model, I think I can figure it out. Can you? This week you are going to practice visualizing and drawing tape diagrams that match what you visualize. Then you'll use those tape diagrams to help yourself decide whether you need to add or subtract. You are going to see this week you have 10 word problems that you can use to help yourself practice visualizing and drawing a tape diagram that matches what you visualize, and then use that tape diagram to help yourself solve the problem. The problems will have green numbers and blue numbers. You get to pick whichever set you'd like, but make sure you stick with the same color for the problem that you're on. So when we look at the example you see on your screen, I chose the green numbers. So I've labeled my tape diagram with just the green numbers. You'll do the same thing when you do your work in your notebook this week. I know you will do great this week with reading, visualizing, and then drawing a tape diagram that matches what you visualize. That tape diagram then is going to show you what you need to do to correctly solve the problem. Have fun, and thank you for working with me today.